All right, so we're going to continue with quadratics. This is 8.4, if you had a book, chapter 8.4, which you don't have a book, so I guess that doesn't really matter. We're continuing to talk about quadratics, and I'm just going to point out a few things. First of all, area. In quadratics, because quadratics are squared, right? When we have length and width of rectangles, or we're finding area of rectangles, they can be modeled with quadratics. So let's just make a rectangle and say this side is x minus 2 and this side is 3x plus 4. Those are the two sides. To find the area, we multiply those together, 3x plus 4 times x minus 2, and we multiply that out and we would get 3x squared minus 6x plus 4x minus 8, which is 3x squared, nope, still minus 2x, and minus 8. And there's our quadratic. If we take that quadratic and graph it, we'll see that there's a point where that's our maximum area that we're going to get out of it, and then it's going to go back down, right? It's going to make a parabola. Or I guess we could have a couple of maximums. So we can use this to show as x increases on this length versus this length, where would we find our maximum area, that sort of thing. And yeah, you could find your y-intercept. This is in standard form, so you should know how to do that. You should be able to find the vertex. And because this is a positive, our a value is, well, we're not going to worry about that. Anyway, so we can use it to model our areas, and as we model our areas, we could graph that. All right, vertical motion. Maybe I should have done this in another color, but too late now. Okay, vertical motion, we have the function h of t, so the height based off of the time is equal to negative 16 t squared plus whatever the initial velocity, v0, was, times time, plus the initial height. And this comes, we have a squared term because of acceleration in the reverse. So we have acceleration acting against it, our initial velocity acting for it, and the initial height acting for it. And again, we can graph this, and it gives us a curve, a parabola, that is a pretty good model for vertical motion. And then the last thing that we're not really going to go over. Yeah, so we'll just leave it at these two. The third one is if we have time at the end of the year, we might come back to it, but, and there's the bell. But for now, we're just going to leave that one alone. It's quadratic regression. It helps you find information about data. So if you have data that's in a quadratic, it can help you find what fits and what doesn't. So if we have time, we'll come back to that. We're just trying to get everything in that we can this year. All right, so area, you can find a quadratic to set up the area and figure out where's your maximum area, where's your minimum area going to be. And same thing with vertical motion, you can have a graph that'll show you can figure out where the maximum height is, when is it going to hit the ground again, is what goes up must come down, something like that, and how fast things will be traveling. Vertical motion. Okay. I guess not really how fast things will be going. You don't have a v final. But the height, we can figure out the height, and we can figure out how long, height and how long. All right, that'll do for this video. It's just the intro.